SP8 work and power. You still need the equations from paper 1 in chapter 3, so you still need GP equals mgh, or mass times gravitational field strength times height. Kinetic energy, which is a half mv squared, and also you need the efficiency, which is useful energy out or useful power out divided by the total power in. So these three equations you still have to remember from paper 1, because quite often in paper 2 on work done and power questions they will expect you to be able to use those equations as well. So GPE, kinetic energy and efficiency, all things that you still need to be able to use in this chapter 8 and 9. So this chapter specifically is about work done, equation for which is force times distance, and power, which is energy divided by time, or work done divided by time. So what that means is, the work done on an object is the energy transferred to the object by force. So if you apply a force on an object to make that object move, for example, if I apply a force on this book and I make it move from there to there, then I've just done work on the book. And what that means is I just transferred energy to the book by force. Alright, so work done is energy transferred to an object by forces. And very specifically, the distance that the object moves has to be in the same direction as the force. So for example, if I apply a force on the book in this direction, then the book moves in this direction, then I've done work. But there are examples which we'll look at in a second, that if the object's displacement, if you want, the distance it travels is not in the same direction as the force, then no work is done on that object. Alright? So very simply, if I apply a force on an object and it moves a specific distance, then the work done, or the energy transferred to that object, is the force applied times by the distance travelled, the units of which, the standard units of work done, because it is an energy, is joules, but because the equation is the force applied to the object times by the distance that it moved, then you have newtons and meters. So the units of work could be newton meters. Alright, so it's joules or newton meters is the true unit. Now, the very same thing, if you want to do work on an object, but you're doing work on the object vertically, for example, if I want to do work on this bag, and I want to lift the bag from the ground, so I put it on the ground, and I say the table is around 1 meter high, and I want to apply a force on the bag upwards, I want to move it a meter off the ground and place it on the table. I've just done work by transferring the energy to the bag by applying a force a specific distance vertically. Now the force that I applied, if I want to do work vertically, I have to apply a force, and it had to move in the same direction as I was applying the force. But if I do work vertically, the force that I need to apply on an object to lift it has to be at least the weight of the object. So if the bag has a weight of 10 newtons, and I want to lift it off the ground, the weight of the object, for example here, the weight of the object is pulling the object down. If I want to lift it up off the ground, I have to at least match the weight of the object. So the force that I do work on this bag with, to lift it off the ground, the force is equal to the weight of the bag. If I raise the bag at constant velocity, for example. So if I apply a force which equals the weight, then the force is up and down the balance, in which case the bag will move off the ground at constant velocity. Now if I apply a force upwards that is greater than the weight, then that bag is going to accelerate off the ground. But just as a bare minimum, all we need to say is the force upwards, the force applied to an object when raising it vertically, is equal to the weight of the object. If they give me the mass in the exam, then I can use the mass, times it by g, find the weight of the object, and then assume that force is the force that I'm doing work on the object with. And then the distance, vertically, is what we call height. So if I do work on an object vertically, the force times the distance is the weight of the object times the height that it moves, which is exactly the same as mgh, which we know is GPE. So if you do work on an object vertically, essentially you are transferring energy to gravitational potential. It's the same thing. Force times distance is the same as mgh, GPE, gained by the object in the vertical direction. Alright, so that's work done. Now, because we said the work done on an object the force has to be in the same direction as the distance moved, an object that moves in a circle has a centripetal force acting towards the center of the circle. However, the distance that the object moves around the circle is specifically perpendicular to that force. it's not in the same direction as the force is acting. It doesn't move inwards, it moves around the circle. And as a result of that, no work is done on an object that moves around in a circle. For example, if the Earth is orbiting the Sun, the centripetal force is gravity. Now, as the Earth moves around the Sun in 1 year, no work is done on the Earth. No energy is transferred to the Earth by the centripetal force of gravity the whole time it orbits around the Sun. Because work done has to be in the same direction. The force and distance have to be in the same direction. And finally, power. So the equation we have for power is power equals energy divided by time. You have to remember that for the exam. Because we just said work done is a type of energy transfer, the power can also be work done divided by time. So you may see it in two of those versions, but it's the same thing. And if we go over here, we look at the units. If power is energy divided by time, then the units are joules per divided by second. So power is joules per second, and the unit that we use for that is watts. So 1 watt of power is 1 joule transferred every second. Alright? So if you're expecting a question on power, look for watts. And if it's not in watts, for example, it could be in kilowatts or megawatts, you need to convert that back to watts. The energy given should be in joules, not kilojoules, not megajoules, and the time should be in seconds, not minutes, not hours. You need to be careful and make sure if you have a question that's asking for you to calculate power, or for example it rearranges it and asks you to calculate energy, the power should be in watts, the energy in joules, and the time in seconds. Unless they ask you for an energy, which could be power times time if you rearrange the equation for energy equals power times time. The power could be given in kilowatt and the time could be given in hours. That is actually a unit for energy, is kilowatt hours. Alright, generally used to discuss bills in a house, electricity bills for example in homes. You would use kilowatt hours to calculate your energy consumption in the home. So that is something they could give you. All they're doing is rearranging the equation for energy equals power times time, using your power in kilowatts, your time in hours, multiplying those two units and getting kilowatt hours. Alright, so another unit for energy is kilowatt hours, and we know the definition of power is the amount of energy transferred per second. The only other thing I've seen in an exam where they've tricked people out is when they say the power or the power density of a substance or an object is in watts per kilogram, for example, or watts per gram, and then they ask in the answer, calculate the amount of energy transferred in 1 second. They're not asking you to calculate energy. They're not expecting you to pull out one of the equations for energy. They're saying calculate the energy transferred in 1 second, which means they want you to calculate the power. So energy transferred per second is power. They could either say calculate the power and you go straight to the equation, or they could say calculate the energy transferred in 1 second. It's the same thing as power. Alright? And that's it. Work done, power, and all the equations that you could be expected to use. Same again, if you're expected to use Gp equals mgh, kinetic energy equals half mv squared, you still have to use the idea of energy transfers, conservation of energy. Nothing can be created or destroyed, it can only be transferred between forms. They could ask you to say, what's the transfer in a cyclist riding a bike? For example, it would be the kinetic into the brakes, which is transferred as heat, thermal energy to the surroundings. All those different processes of energy transfer also apply to this chapter on chapter 8 as well.